Hello guys, good morning, good afternoon. My name is Mr. Mulenga. Today I want us to look at mathematics and topic in particular called formulating algebraic expressions. Today we'll be looking at how we can formulate the algebraic expressions. Now, to start with, we need to understand the word. We need to understand the algebraic expressions. What are they? Because if we don't know them, then it becomes difficult for us to deal with what we don't know. So, what is an algebraic expression? This is a mathematical sentence that does not have an equal to sign. Now we're saying an algebraic expression is nothing other than a mathematical sentence. Now in that sentence, you don't expect to find an equal sign. And we all know what an equal sign is. So such a sign is never found in an algebraic expression. But rather, what you find are these signs. The only signs that you find in this algebraic expression that we're dealing with are a positive sign as well as the negative sign. The moment you get to have an equal to sign, it means that is not an ordinary algebraic expression, but it will be called an equation. But we are not yet dealing with equations. We're just looking at the introductory point of it. Now, having looked at the definition of an algebraic expression, I'll give you an example of an expression, then you understand every aspect that is found therein. So the example of an algebraic expression can be, you can have 3x plus 10. That is an example of an algebraic expression, 3x plus 10. Now, let's understand every entity that is found in here so that it becomes easier for us to be dealing with things that we know. Now, in here, we can see that the 3 is written before the letter x. So that number 3, we are going to call it coefficient. The number 3 is called coefficient. Then this letter x is called variable. But it's not always that a variable should just be x. The variable can be y, can be m, can be l, any letter that's found in the alphabet. When you written the mathematical sentence, that letter becomes a variable. Then there's also this number 10, which does not have any variable. Therefore, this number is called the constant. So, most of the times, the algebraic expressions will contain these three things. One, we're going to have a coefficient, we're going to have a variable, as well as the constant. Now, let's understand these three things. What is a coefficient? A coefficient, like in our case where we had the 3, this is just a number. This is any number. Any number that is written at the beginning, or we can say that is written before a variable. Written before any variable. That is written before any variable. So if you look at the way the number which is written before the variable x, in our case, is 3. So we can say 3 is our coefficient. So we understand that the coefficient is a number that is just written before any variable. The variable can be m, the variable can be l, the variable can be y, any letter, a number that is written before any letter of the alphabet, that is called a variable. Now, what is a variable? Okay, what is a variable? A variable is any letter. A variable is any letter. Like I said, any letter, and this letter can represent any value. Okay, so you're saying a variable is any letter that can represent any value. Now, what do I mean? You can have a variable such as L, which can represent 2. We can have a variable such as L, which can represent a number 2. So a 2 is a value that the variable is representing. Then we've looked at what a coefficient is. We also looked at what a variable is. Now let us understand what a constant is. So a constant, like in our case, the constant, if you can see here, the constant is 10. So in our case, how can we define a constant? We are saying a constant is any number, like you can see here, is any number that does not contain a variable. So a constant is any number that does not have a variable. So we can also have another expression, maybe such as 4m plus 7. So 4m plus 7, in our case here, the 7 which does not have a variable, it is a constant. Our m here is a variable, and our 4 here, which is written before the letter m, is a coefficient. Okay, so now let us understand the, one more thing about these algebraic expressions. Let us understand one more thing about these algebraic expressions. All right, now, how can we simplify these mathematical sentences, which we've called the algebraic expressions? How can we simplify them? Okay, so how can we simplify them? So we're going to say simplification of algebraic expressions. Simplification of algebraic expressions. Okay, now, under simplification of algebraic expressions, there are two important terms that we need to understand. There are two very important terms that we're going to encounter every now and then as we do more of the algebraic expressions. What terms are they? The first term, the first thing is called like term. Like term as well as the unlike terms. Like terms and unlike terms, these are very important things that we need to understand. We need to understand more of them so that even as we do much of the algebraic expressions, at least we'll have somewhere to stand. What are like terms? These terms, like terms, these are the terms that contain, these are the terms that contain the same variable as well as the same power that is written on the variable. What do I mean? We can have an expression. We can have an expression such as we can have an expression such as 4x squared minus 3x minus or plus 3x squared plus 2x. So that is an algebraic expression that we have, and if you can look through it, we can find that we can confirm that there is no equal sign. There is no equal sign throughout. Therefore, this qualifies to be called an algebraic expression. If we had an equal sign in any of the positions, this could have been called an equation. Now, from this simple example that we have, we're saying these two items are very important, like terms as well as unlike terms. When you start looking at the simplifications of these algebraic expressions, we're going to rely much on the like terms as well as the unlike terms. What did I say about like terms? Like terms are those terms that contain same variable as well as the same power. Now, what is a power? The power is a number that is written on top of the variable. So from here, we can see that this 4x has got a power which is 2 for x squared. Even this 3x also has the power which is 2. So these guys have got the same variables, which is x squared, with the variable which is x and x here, and the powers are the same. But look here, this 3 has got the power which is 1, an invisible 1 right over there. Even this 2 has got an invisible power of 1. So these guys also are like. So the negative 3 and the negative 3x and the positive 2x, these also are like terms. Okay, so what can we say? We can say 4x squared and 3x squared are like terms. Okay, so I'm going to say that this 4x squared as well as the 3x squared are like terms. What other like terms do we have? The other like terms that we have are negative 3 with the x having the power 1, and the 2x are also like terms because they have the same variables as well as the same powers. So the coefficient on the variable does not matter. As you can see here, the coefficient here was a 4, the coefficient here was a 3. So we can see that the coefficient has got no role to play in identifying which one is a like term and which one is not. So if these two are like terms and these two are like terms, these two are like terms and these two are like terms, therefore we can say that these guys are unlike terms. So what can we say? We can say that 4x power 2 and minus 3x are unlike terms. Why them being unlike terms? Because they have got the different powers. Here the power is 2, here the power is 1. These guys are unlike terms. In a similar manner, even these other two terms are also unlike. So the other thing that we can say is that 3x squared and the 2x are also unlike terms. But why is this important? Because When you be simplifying, we'll be adding or subtracting those terms that are called like terms. When it comes to simplification, we'll be dealing with those terms which will be identifying as like terms. We cannot add or subtract the terms which are not like. All right. With all that said, then we can move to the next step and look at the examples. Okay, move a bit further and look at the examples. 3 examples. I'll just put across 3 examples. Thereafter, I'll send an attachment that will contain some individual work that everyone of you guys will be attempting in trying to see if you are going to understand what is being presented. So examples. Simplify each of the following expressions. What expressions are they? Expression number 1, 7x minus 9x plus 8. Question 2. The expression is 2x minus 4y plus 5x is plus 8y. Then the third and the last expression is 9y plus 6x plus 4y plus 7x. So these are the expressions that are given before us. Simplify each of the following expressions. First thing first, we need to identify the like terms in each of those expressions. Okay? Having done so, then I'm going to give you a very important tip. I'm going to give you a very, very important tip. Now, which one is it? Always and always remember this. Whenever you are simplifying expressions that have different signs, which signs are they? Positive sign as well as negative sign. When you are dealing with such expressions that have different signs, what are you supposed to do? So the tips are very important. Tip number 1, when you simplify expressions, we say 2 expressions, 2 expressions within signs. Different signs. Which signs are they? You're going to have a plus and the minus. What are you supposed to do? All you have to do is subtract them. Subtract them and obtain the overall sign from a big number. From the bigger number. This tip is very important. It's going to guide us, going to help us went through. So when you're simplifying 2 expressions that have different signs, a positive sign as well as a negative sign, all you have to do is subtract them regardless of the way they are presented. You can have expressions such as -4 plus 2 which is the same as 2 minus 4. All you have to do is subtract them. For as long as in the expression you have two terms or two numbers that have different signs, all you have to do is subtract them and get the overall sign from the bigger number. So ignore the signs. Okay, so here what you have to do is you subtract a 2 from a 4, that will give us 2. Then ask yourself which one, ignore the signs, and then ask yourself which one is a bigger number, which number is bigger than the other. Between 2 and 4, find that 4 is that we get to have a negative sign. In a similar manner here, when two signs are being presented in the expression, all you have to do, subtract them, get the sign from the bigger number. This is what you'll be dealing, will be applying in the expressions over there. That is tip number 1. The second tip is that when you are dealing with two expressions with the same sign, same sign, all you have to do is just add them and pick a single sign. Pick a single sign. Single sign. What example can you look at? When you have -2, -4, or a +7, a +10. If you look here, both terms or both numbers have got same signs. Like the statement is saying, we're dealing with two expressions that have the same signs, add them. In the regardless of what that sign is. The sign can be negative, the sign can be positive. So in this case, what I thought is we need to add them and then just pick a single sign. So when you add the 2 to 4, we're going to have the answer, which is 6. But what is a sign? Just pick a single sign, which would be -6. Different from what we had earlier. In a similar manner here, when you have +7, +10, all you need to do is add them, then pick a single sign. So what is the answer when you add 7 to 10, which is 17, and the overall sign is positive. Therefore, the answer gets to be +17. All right, getting back to the questions that are before us. Getting back to the questions. All right. So the question says, simplify each of the following expressions. The first expression that we have, number 1, we have 7x minus 9x, then plus 8. So first thing first, like terms. So we're going to add these. We're going to deal with these terms that are alike, because this guy has got a coefficient as well as a variable, the power 1. This guy also here has got a coefficient and the variable, which is a power 1. This one is a constant, does not have the variable. Therefore, these terms are the ones that are like that we're going to add. Now remember, the first statement that I gave you was when you're dealing with two different expressions that have got two different signs, all you have to do is subtract, get the sign from the bigger number. So when you subtract 7 from 9, you are going to have 2. The variable is x. So when you subtract 7x from 9x, all you're going to have is 2x. But then ask yourself, between 7 and 9, which number is bigger than the other? The number which is big here is 9, and the sign is minus. But if you look at this, like this term here, which is 8, which is a constant, it does not have any other term that it is likened unto. So therefore, we're not going to add it to any number. Therefore, the answer becomes negative 2 plus x. We go to question number 2. Question 2, we have 2x minus 4y plus 5x, then plus 8y. First thing first, like terms. So what terms are here? So we have 2x plus 5x. These guys were done. And then minus 4y plus 8y. Like terms, these terms are alike. These terms are alike. Okay, so the second point was when you have two expressions that have the same sign, what do? You add them and then pick on a single sign. So you add 2x plus 5x, and then you have 7x. But both of them here are positive, therefore the overall answer becomes positive. We get to the other side of the expression. We are having now two different signs. The second point was, the first point was when you have two different signs, all you have to do is subtract them and then pick a single sign from pick the sign from the bigger number. So you subtract the 4y from 8y, we're going to have 4y. But between 4 and 8, which number is big? It's 8. What is the sign? It's plus. So the overall answer becomes 7x plus 4y. We get to the third and the last question. We have 9y plus 6x plus 4y plus 7x. First thing first, like terms. Okay, so we're going to group those terms that are like. So we are going to have 9y. We also bring this 7. We're going to bring this 4, which has got a y, but the sign on the 4 is positive, so positive 4y. Then plus the 6x here. Then we bring also the 7x around here. Here our work is so easy. Why? Because throughout the sign is the same. So we're just going to add these like terms here. We also add these like terms here without considering which sign are we going to pick on. So when you add 9y to 4y, we are going to have 13y. Again here, the sign is just the same, which is positive. So we're going to have 6x plus 7x. That is going to be is going to be 13x. Both of them have positive sign, therefore we are just going to pick only a single sign. So that's how we can deal with the expressions that are having different signs. When signs are different, all you have to do is subtract them and get the sign from the bigger number, regardless of the way they are presented, the negative starting or the positive starting. Just follow the tips that are given you. And when you are dealing with expressions that have got the same numbers but same signs, provided those are like terms, all you have to do is add them and pick on a single number. Pick only a single sign. All right, so that's where we end on today's presentation. I'm going to send you the exercise that will be attached at the end of this. All right, bye. Enjoy to mask up. The COVID is real. Yeah.